Hi everyone, I am Prasad. Welcome to Professor Spark channel. This is ninth class for electrostatic chapter. Let's go to solve some problems. Say a rectangle is given whose sides lengths are 4D and 3D. At the corners 3Q minus 3Q, 4Q minus 4Q are given. So what is the electric field at the point P? P is intersection of two diagonals. Lengths of these two diagonals are same. Diagonal intersection should be midpoint of these two diagonals. So point P is at the same distance from all four charges. So we want to calculate half of the diagonal. Before that, what is the length of this diagonal? So this is the right angle triangle and this is the hypotenuse. So hypotenuse square is equal to side square plus side square. 4D whole square, that is 16D square, 3D whole square, that is 9D square, 16 plus 9, 25D square, 25 is 5 square, so this square all cancel, so hypotenuse is 5D. So point P is exactly between mid of 5D, so this is become 5D by 2 and this become 5D by 2. 3Q and minus 3Q are the same distance from the point P, so their magnitudes become equal. So E electric field due to 3K and electric field due to minus 3Q, both magnitudes are same because both are equal distance. So that magnitude is minus 3Q by distance is 5D by 2. D square means 5D by 2 whole square. So this is a modulus. 5D whole square by 2. So that is 25D square by 4. So this is 4 into 3, 12. Modulus of minus, that is plus 1 by 4 pi epsilon q by d square, that is E. So that is equal to 12 by 25 into E. Magnitude of electric field of 4Q is equivalent to electric field of minus 4Q because both are equal distance from point P. So that is equal to 1 by 4 pi epsilon naught. Charge is 4Q by distance is 5D by 2 whole square. So that is 25D square by 4. 4 go to numerator. 4 into 4, 16. So this is 16 by 25. So this is E. So this is 16 by 25 into E. So at the point P, there is unit positive charge. 3Q repels unit positive charge along this direction. Minus 3Q attracts along this direction. So these forces are the same. 4Q positive charge repels along this direction. Minus 4Q attracts unit positive charge along this direction. See, these two vectors are in the same line. These two vectors are in the same line. So their magnitude is sum of magnitudes of two vectors. First I calculate along this direction. Magnitude of E minus 3Q is equal to 12 by 25 into E. Magnitude of E4Q, that is equal to 16 by 25 into E. So both are in the same direction. So E resultant of minus 3Q and 4Q is equivalent to sum of 12 by 25E and 16E by 25. 12, so here denominators are same. So 12E plus 16E, that is 28E, is 28E by 25. Here now come to these two. E due to 3Q, that is 12 by 25E. E due to minus 4Q, that is equal to 16 by 25E. So resultant of this 3Q minus 4Q, that is equal to 28e by 25. So these two vectors are same. For convenient, 28e by 25 considered as x. So these magnitudes x and x makes an angle how much? Perpendicular line to the exactly bisect this side, so it becomes 3d by 2 and this become 3d by 2. D by 2 is multiple of 5, here d by 2 is multiple of 3, so 3 4 5 are the group of right angle triangle, remember. So this is 5 3, so this is 4d by 2. So suppose the angle is alpha and this is alpha, so 2 alpha is angle between these two vectors. So I want to first calculate the alpha. Cos alpha is equal to 4d by 2 by hypotenuse 5d by 2, 2 cancel, that is 4 by 5. What is cos 2 alpha? 2 cos square alpha minus 1. So we have this formula. So from this formula, cos 2 alpha is equal to 2 into, so what is the cos alpha? That is 4 by 5 whole square minus 1. See, 16 by 25. 16 into 2, 32. 32 by 25. See here, 25 into 1, 25. 32 minus 25, that is 7. 28e by 25 and 28e by 25 make an angle 2 alpha. For convenient, it is considered as P. So P and cos 2 alpha. So E resultant, that is equal to square root P square plus 2p square cos 2 alpha. So cos 2 alpha is 7 by 25. So 7 into 2, 14 by 25. P square plus p square, that is 2p square. See here, 25 into 2, 50p square, 50p square plus 14p square, that is 64p square by 25. Root 64, 8, root p square is p, root 25 is 5. 8 by 5 into 28 by 25 into e. So 25 5s are 125, 8 8s are 64, 8 2s are 16, 16 plus 6, 224 e by 125. So this is along this direction. So E resultant is 224 by 125 e along this direction. Some equal charges are placed at equal distance on circle. Find electric field strength at center of the circle. Suppose we take two charges on the circle which are placed at equal distance on the circle. Suppose both charges have QQ. These are at equal distance from the center. Electric field intensity at the center mean at the center there is unit positive charge. So Q repels unit positive charge on both sides in opposite direction and having same magnitude, so resultant become 0. So for two charges, resultant vector become 0. Suppose we take three charges, so all charges having same charges, so at the center unit positive charge, Q repels along this direction, this Q repels along this direction and Q repels along this direction, and angle of these two vectors are same, so assume angle of vector is x. So sum of these three angles, that is equal to 3x, that is exactly equal to 360 degrees. At the center for quad circle makes an angle 360 degrees. So what is the x? That is 120 degrees. So this is 120 degrees. See here, magnitudes of these three vectors are same. Assume magnitude of these vectors is E. First I want to calculate resultant of these two. Here the magnitudes are E and E making an angle 120 degrees. So E resultant vector, that is equal to square root of E square plus 2EE cos 120. Cos 120, that is equal to cos 90 plus 30. Cos 90 plus 30, that is minus sin 30. Minus sin 30 means minus 1 by 2. Cos 120 means minus 1 by 2. Plus into minus, minus 2 cancel. E into E square. E square cancel. Root E square is E. So resultant vectors of these two is E and makes bisect equally this angle. This is 60 degrees. So 120 plus 60, that is 180. So resultant of these two is exactly opposite to this one and magnitude is E. So total resultant of these two vectors is 0. So for 3, electric field at the center is 0. Suppose if you take 4 charges, so these are the placed of 4 charges on the circle at equal distances. So at the center unit positive charge. So this Q repels along this direction and this Q repels along this direction and this Q repels along this direction and this Q repels along this direction. See here, all vectors having same magnitude. Suppose I take these two, so both are in opposite direction, so the resultant is 0. Here also these two vectors having same magnitude E and E and both are in opposite direction and resultant is 0. So for 4 vector, resultant vector is 0. Suppose we take 5 equal charges on the circle at equal displacements. So at the center unit positive charge. So Q, this Q repels along this direction and this Q repels along this direction and this Q repels along this direction and Q repels along this direction and this Q repels along this direction. See, 5 equal vectors are acted at the point center. Angle between these two vectors is taken as x. So remaining all are also x. So total are 5xx. So 5x total angle at the center. So that is 5x. So we know at the center for whole circle it makes 360 degrees. So what is the angle of x? That is 72. So this is 72, this is 72 and this is 72, 72, 72. See here, first I take resultant of these two vectors. So their magnitudes E and E, angle between them 72 plus 72, that is 144. So resultant of these two vectors is equivalent to E square plus E square plus 2 into E cos 144. 2 into E, that is 2E square. E square plus E square, 2E square. 2E square, suppose we take the common, then we get 1 plus cos 144. We know 1 plus cos 2 theta, that is equal to 2 cos square theta. 1 plus cos 144. That means 144 means 2 into 72. That is 2 cos square 72. So 1 plus cos 44. That is 2 cos square 72. So root of 2 into 2. That is 2. Root is square easy. Root of cos square 72. That is cos 72. So this is E resultant vector. So what is the direction of these two? Direction of these two. Say resultant vector exactly bisect this angle 144. So we get along this direction of E. So that is 2E cos 72. See here E and 2E cos 72 are in the same direction. So their resultant is addition of these two vectors. Then we get E plus 2E cos 72. That is E common 1 plus 2 cos 72. So resultant of these vectors is to E cos 72 E plus 2E cos 72. So we get one vector. Okay. Next, resultant of these two vectors is, so what is the magnitudes? A and E and E, and angle is 72. So E resultant of this one is correct. E square plus E square plus 2 into E cos 72. 2E square. 2 into E, that is 2E square. E square plus E square, that is 2E square. 2E square is the common in both terms. Then we get 1 plus cos 72. 1 plus cos 2 theta. That is 2 cos square theta. We know that formula. We have formula 1 plus cos 2 theta is equal to 2 cos square theta. So 1 plus cos 72, that means 2 into 36. 1 plus cos 72. 72 means 2 into 36. That is equal to 2 cos square 36. So 1 plus cos 72, that is 2 into cos square 36. So root of 2 into 2. Root is square easy. Root of cos square 36, that is cos 36. So 2E cos 36 is exactly bisect 72 angle. So this is 2E cos 36. So 72 angle is bisect. So this angle is 36. See here, this 72 plus 72, that is 144. 144 plus 36, that is 180. So this total angle is 180. See here, this result in two vectors is 2E cos 36. So both are in opposite direction. So resultant of these two vectors is subtraction of these two vectors, that is E 1 plus 2 cos 72 minus 2E cos 36. Suppose E is the common, then 1 plus 2 cos 72 minus 2 cos 36. Suppose E is the common, 1 plus 2 cos 72 minus cos 36. That is equal to E into 1 plus 2 cos 72 that is equal to 0.3090 minus cos 36 0.8090, that is equal to E into 1 plus 2. 0.3090 minus 0.8010, that is minus 0.5. So plus into minus, minus 2 into 0.5, that is 1. 1 minus 1, 0. So we get resultant vector of these 5 vectors is 0. So there are 5 charges along the on circle at equal distances. Then electric field strength at the center is 0. Suppose we take 6 charges at equal distance on the circle. So everyone has exactly opposite diagonal end of charge. Unit positive charge is repelled by both in opposite direction. So resultant vector become 0. Sum of all resultant vectors of this is 0 at the center. Suppose some vectors whose magnitudes are equal makes an equal angles with each other, then resultant of these vectors become 0. Take any number of equal charges at equal distances on the circle, then electric field at the center is 0.